Right. Good morning, everyone. Good morning, our class of 2020. Right. I hope you had a wonderful week. Right. We want to continue our discussions on developments. In particular, we are looking at transition pieces. For today, we are going to look at the square to square as well as the rectangle to circle transition piece. Right. Remember, when we look at transition pieces, these are basically part of the big family of developments, right? And when we look at transition pieces, they've got so many applications in industry. I'm going to read the definition of transition piece as according to the source from the internet. Transition pieces are usually made to connect two different shaped objects, e.g. round pipes to square pipes. As often found in ducting for air conditioning or dust and fume extraction systems. The development is constructed by assuming the surfaces or the surface to be made from a series of triangular surfaces laid side by side. But when we talk about those triangular surfaces, right, it now brings to the fore the issue of the method that we want to talk about or that we want to reinforce, which is triangulation. Triangulation is a geometric development process used to create patterns of conical and transition shapes by creating true-sized triangles laid side by side. So we are going to look at the construction of a development, in this case, a development of a transition piece when we are using the method of triangulation. So I want you to pay attention. If you have got any questions, I want you to forward those questions so that we can iron out issues of concern. Enjoy the lesson. Remember, we want to be practical as always. So I want you to take a pen, pencil, a drawing board, and a piece of paper and follow the steps that we are going to do right now so that you can also have the same understanding as I do. And that would translate into application. Enjoy the lesson, boys and girls. Right, there you go. Right, we have got today, right, this particular setup, right, there is a square base as well as a square, right, but sitting at a corner, right? So I want us to be able to look at this, and this now refers to the transition piece. Required. Let me just read the instructions for you so that you understand what we are talking about. Right, this is actually from a past exam paper. Question number 2, transition piece. The front view and top view of a square to irregular four-sided transition piece. Draw to scale 1:1 the following views of the transition piece. The given top view, right, which is this one, the top view. The given front view, which is this one, the front view, and the development of the transition piece. Right, so from a square base and to another square, but which is a bit irregular, as you would see. Right, so we are going to construct the development of this part which is in transition, which is changing from one size to the other, from one form to the other. Right, not AB is the seam, right? This is point A, this is point B, that is the seam, right? That is where we are going to open through. So I want us to start the process, right? Remember, we are supposed to copy these views. I'm going to do that now, right? I will start by drawing a faint horizontal line like this. bring in, there you go. Right. The square, the big one, is 54. So measure 54. Draw a faint vertical line. Right. Take a 45-degree set square. Right. I'm just going to miter here. Like that. There you go. So that is the square part, right? Which is 54 in terms of the side. I'm going to outline this. There you go. Right, so the square is defined. Let me find the center. Faintly. Like that. Right, now if the square is sitting at a corner like that, right, you take this one up. We shall need that. Right, you take half the side of this square is 24. So half of the side is 12. Then at 45 degrees. Like that. Right. Then I can outline this. Here we go. Right, as you can see, there are now lines which are connected to there. So the triangles are already there. Right, we are not going to define any triangles. So I'm going to connect, start faintly. Right, I can outline this. There you go. Okay, that's our top view. Right, then I would create a ground line, right, just somewhere in between, like this. Right, I can label this one X and Y, okay? Right, have a starting position, like that. Then measure, right, from this point, right, which is from here to there, the perpendicular height, but referring to this point, which is that point, which is 75. So I need to extend this one up. Right, and also this one. There you go. 75. Which is connected to this one. Right, this one is 50, which is a reflection of this point, which is that point. So I'm going to measure 50. Which is this one, connected to the 75. And this is connected here. Now I'm going to outline this. There you go. Right, so there is also an edge, a reflection of this one to that point, which is that point. So I'm going to define that one as well. Just outline using a pencil. Okay. Now I have got the setup in terms of the top view as well as the front view. Right, the next thing that I want to define as well is the seam. Let me use a different, this one here. That's our seam. Right, I'm going to say this is point 1, and this is point 2, and this is point 3, this is point 4. The upper one, we know we are given this one as point A, but I'm going to change it so that we simplify our discussion. Right, then this one is point A, B, C, D, and this one, which is the seam 1 to A, right, which 1 to E, which is our seam line. Right, now this is also the seam, right? I'm going to write like that. That's the seam, and as you can see, 1 to E, right? If we label here, we have got C and B, then we have got point number 3, right? We have got point 4 and 2, we have got point 1 here, then we have got D and E as well as A at that point. Now, if you check 1 to E is parallel to the ground line, therefore, this one which is inclined is therefore a true line. So note that one, this is already a true line. The seam line, which is this one, is already a true line, okay? Now, the next thing that you want to do, right, you can go back to your questions, right? I've drawn the top view, I've drawn the given front view. Now, what I need is to come up with a development. But to come up with a development, you need, first of all, to create a series of triangles. Those triangles are already here, okay? Then, once we have defined those triangles, I'm talking about this, that's a triangle, that's a triangle. Once we have defined that, the next thing that you require is to find the true line, okay? Like I've already alluded to, this line 1 to E is the same as that one, which is already a true length. Now, let me take this one, right? I want to label this. This is, I'll call it line A, right? Like that. The other line, which is similar to this one in terms of size and everything and point of connection, is this one. So this one is also line A, right? I would say this is point line B, right? Line B, this also is line B, like that. Right, so I have B and B, right? If you check this from D to 4, D to 4 is the same as C to 4. So this one would also be equal to line B, like that. Then this one, I would say this is line C and this is line C. Right? So I've got A, B, this is also B, which is also B, and this is also B, this is C, this is C, okay? Right, the next thing that I need to work on is to find the true length, okay? Right, let me start with this one. This is 1 to A. Right, I'm going to use the method of rabating. Extend this. Describe an arc like that. Then project this one up and extend this one to there, okay? Right. So if I'm standing here and open to point A, right, from here to there, right, point 1 to point A, right, which is the same as point 1 there, but I'm going to shift point A to this new position and I will create this one like that. Let me use a different color. There you go. Right, okay. Right, this is line A. So when you require A, you are not going to take from here, you are not going to take from here, okay? You are going to take from the true length. So the true length of 1 to D as well as 1 to A is that one. Right, then the next one that I require is line B, right? I need the true length of B, right? I can swing like that, standing at point A, okay? Stand here, then swing. So what I'm going to move is point number 2, right? Which I'm going to extend like this. Then take this one now, go up there, okay? Right. A is the same point, which is here, but 2 has shifted from here to that point. So I'm going to connect like this. And again, I'm going to use a different, show it by way of dotted lines. Like that. So this is the true length of line B, right? True length B, okay? Right, which is that one. So if I need this one, if I need that one, if I need this one, I not need that one, I will take from there. The next one that I require is line C, right? I can swing this, just extend, stand at point 5 and up. Right, so from 3, this is now the new position for point C. Use a different black. Okay, so this is line C, right, which is the true length of line C. Right, now I have got this one 1 to 2, right, 1 to 2. As you can see, right, 1 to 2 is inclined here and 1 to 2 is also inclined there. So we don't have a true length there, right? So I'm going to project this like that. Then at point 2, and open to point 1. Take this one up, go to point 1, which is here, right? You have got this. That is the true length of 1 to 2, okay? That is the true length of 1 to 2. So you're not going to take from here, you're not going to take from there, because they are both showing in an inclined position. Right. Now, if you want to start now, okay, right, just pick a point, say somewhere here, just mark. This is the point, which is point 1. So I'm going to label that one point 1. Let's label with a clear mark. Right, that's point 1. I need the true length from here to there, which is 1 to E. You take this true length, bring it here, and mark. That is our point E. Right? We can actually outline this. It's not going to change. So you have this line like that. Right. So that is our first line in terms of the development. Right. Now, if you check here, this line 1 to E is meeting A, D, or D, A at 90 degrees. So in situations like that, you can easily draw a faint line like this, measure the distance from E to A, right? Or you can take with your compass like this, take this distance like that, right? You stand at point E and you describe an arc like that. Right. If you join this point to point 1, you're definitely going to produce this line. Okay. So I'm going to faintly connect. Like that. So this is the first panel, okay, right, which is defined in form of the triangle, and this is the true sized panel, okay, right. So you can also outline this like that. Take this distance from here to there, go to this point, you would find that it's one and the same thing. Right. Remember, you can also do the same thing from E to A and 1 to A, which is taking this distance, standing at point E, describe an arc, standing at point 1, which is this point 1, taking the true distance from here to there, you describe an arc. It should still bring you that. Now, once you have gotten point A, okay, like this, the next point that we want to find is point 2. Remember, we are not going to take from here, neither are we going to take from there, because we need the true length. Right, we stood at point 2, rabated like that, took this one up and connected with that. So we are going to take this, right? You take that as a true length, then you describe an arc like this, right? To get to point 2, you need 1 to 2 and A to 2, which is represented by line B, okay? So I'm going to take line B, which is the true length, here, right? Stand at point A and describe an arc. That's my point number 2, which is here. There you go. Then the next thing, you connect. The top part, the outlines, which is 1 to 2. You can outline at the end, but if you're certain you're doing the right thing, right, by any means, you can outline as you go. Right, now I've got 1, E, A, and 2. But 1, E, A, and 2. The next point that I require is point B, right? If you check this one, which is A, 2, 2, which is the same as 2 to B, so I can reverse this, stand at point 2 now, the established point, and describe an arc like that. Take the true distance from A to B. Why? Because this A to B is parallel to the ground line. A to B is also parallel to the ground line. So both are shown as true lengths. That's my point B. Connect to this. Every time define the triangles like that. This line from here to there can be outlined. There you go. I've got point B. Right. Now what I require is point number 3. Point number 3, you don't take 2 to 3 from the top view, neither do you take it from the front view. You take this one. We have already said this is our true length in terms of 1, which is slightly bigger than the normal size 24, okay, because of the skewedness of the shape. So I will have described an arc like that, which is this true length, which is the same as that one. But how do we get point 3? Right, it's a combination of 2 to 3 as well as B to 3. Make sure you have got 2 confirmed standing positions. Point 2 is there, point B is there. So for you to reach point number 3, you need to stand at point 2 to 3, point B to 3. Point line 3C is represented by C. So we are going to take the true length from here. Like that. Stand at B, then describe an arc. That's our point number 3. Like that. Then you also connected this. To there, faintly, right, but still showing the triangles that are required. Still showing the triangles that are required. So you can outline this part. Now, if you check from point number 3, we also require line C, which is the same as this one. So I can label this one. This is A, this is B, This is B as well. This is line C, just to confirm so that you relate to the true lengths that we have defined. So I can replace this, right? And then describe an arc like that. The arc should take me to line number 3, point C rather. So I can take from here. This, you stand at point B, you describe an arc like that. Connect. Always define the triangles. Right, this one cannot be outlined. Right, and this is point C. Right, so from the start, right, that's the seam line which is given by virtue of its position. Then we started creating triangles. And these are the true sizes of those triangles in terms of those panels. The triangles are patched together or they are connected together, right, in order to develop the template that we are working on. Right. I now have got point C and point 3, point 3 and point C. The next one that I want is point number 4. Point number 4. Right, and point number 4 would come as a result of 3 to 4, right, which is not this one, which is not that one, but which is the true length from here to there, which is the same as that one. So I'm going to take this as the true length, stand here, and describe an arc like that. Then I need line B to get to 4. Line B. Right, I can now go back. Remember, this one is also line C. Take this one, which is B, confirmed. Right, stand here at point C and describe an arc like that. Then I establish point number 4. Connect 3 to 4. Then we do the same. Get a triangle like that. From here to there, that can be outlined. You can outline this. But now that I've got point 4, right, I can get point D, which is 4 to D, D as well as C to D. What is common there is point D, okay, right? As you can see, this is B, right? If I go to D, I need another B. Let me just check if it's still the same. Here we go. Stand at point 4, describe an arc like that. Then take C to D, which is the true length. Can take from the confirmed one. Mark like that. There is point D. Point D is connected to 4, and 4D is connected to C, like that. And this can be outlined. There you go. Right, our development is slowly taking shape. The next one that we require is now point 1. So from 4 to 1, okay? Right, so I need the true length. Right, stand here, describe an arc. Right, then I need 1D to 1, which is line A. Line A is here, or you can take it from the true length diagram. This is our line A. That is our line A. Right, stand at point D and describe an arc like that. Let me just go back here. Now I have got point 1. Point 1 is connected to point 4. And this one to create the triangle. There you go. Right, so this can be outlined. That can be outlined. Right. The next one that we require is point E. Right. So from 1 to E and D to E. Remember, you take the true length from D to E, right, like this. That is the true length, which is the same as that one as well, okay? But you stand at point D, you describe an arc like that. But take the true length 1 to E, which is here, right? You stand at point 1 and you cut this. Right. Therefore, you have defined point E. If you open through 1E, you should end also through 1E. Right. Then you connect. So connect. As you can see, we are also going to create an angle of 90 degrees. Right. One indicator that would show you whether you are right in terms of the angle, especially if you are defining an angle of 90 degrees. This line should be tangential to that, and this line should be tangential to the arc, which is like that. If you find something like that, you know that your constructions are okay. So I'm going to outline here. And also do the same. There you go, boys and girls. We have got the development of that particular transition piece. So if you are going to cut your material, you would cut according to this shape that we have developed. And these would be the fold lines. I'm going to leave these ones as they are, right? Sometimes we find that we show by way of dotted lines here and there, but I'm going to leave them the way they are. Right, I've got 4 to D, right, which is B, right, and this one is A, okay, just for reference purposes, right. Then the last thing that you need to write or indicate, right, you need to show this is the development transition that is the development of the transition piece. Right, I hope you were able to follow all the steps that we were making in coming up with this development. So next up, we are now going to look at the development of a transition piece, but which is defined by a rectangle and a circle. Right, I also want you to make sure that you understand all the steps that we are going to have. I'm going to remove this and bring in right this paper. Right, this is not from the past paper, it's from a workbook by SHE. Right. There you go. Now, this is what we have. Right, we have got the top view, we have got the front view. Remember, this is in first angle orthographic projection. What it means, you would find this kind of question in paper 1, okay? Right, when the front view is at the top, and the top view is at the bottom like this, that's first angle orthographic projection. Let me go through the instructions and see if we are dealing with one and the same thing like we did last time, right? The front view and the top view of a rectangle to circle transition piece, right? So we have got the front view and the top view, right? This is the rectangle that is defined as well as the circle, which is at the top. So the circle could mean a cone, the circle could mean a cylinder, the rectangle could mean a prism going downwards, okay? Right? It could also be referring to a pyramid, depending on the design of the mechanism that is required. Right, what are the instructions? Draw to scale 1:1 and invest the angle of the graphic projection, the front view and top view of the transition piece. So we are going to copy this. Develop the surface of the transition piece, show all necessary construction and fold lines. Right, here we are not given specific seam line. Okay, so we are going to create our own according to where we prefer. Okay, right, we are going to create our own seam line. So the first thing I'm going to copy this. So just watch as I'm copying. All right, the diameter of this circle is diameter 42, which means radius 21. Radius 21. There you go. Right, then from here to there, that's 70. Right, I'm going to measure from here, which is the same as this one, 70. Then 63, right, 63 divided by 2, 81.5 either side. This at the top, so let me just extend this. This can be outlined. There you go. Find the ground line, just for reference purposes. But you can say this is X and 1. That's the start. The height is 31. this one to there. There you go. Okay. I can also outline this. Right. Define the center lines. Like that. Remember, center lines are only defined when they are required. Okay. Right. So I have copied the given front view as well as the top view. So I can tick that part is done. But the next thing that we want to look at in terms of developing the transition piece, which is the transition piece, changing from a square base prism or pyramid to a circular geometric solid, which could be a cone or a cylinder. Okay, so we basically say it's from rectangle to circle. Okay, that is the change. So that part which is changing from one form to the other is what we refer to as the transition piece. Right, I'm going to divide the circle into 12 equal parts. Okay. Now I'm also going to label this point, right? I will make this open through here. I will make this one my seam, right? So I'm going to say this is 0.0, this is 1, 2, this is 0.3, right? This is 0.6, this is 0.9, so that we don't crowd the diagram with a lot of labels, okay? Right, I'm going to say this is A, B, C, and D. Right, make this one point E, which is our seam line, and I'm also going to define this one so that we see. Right, that's our seam. Okay, right. Let me write seam. Okay, right. It can also be referred to as the joint line. That's where you are going to join and connect. Now, the next thing is to create a series of triangles. Okay, right, from A, series of triangles. That is number one. Let me use a different pen. So this one. That's one. Two. Three. There you go. And then go to the other side. Do the same thing. And this one is already there. There you go. Okay. Right. So now there are a series of triangles. We can also label this one. This is point C, which is point B in front. This is D, E, and A. Okay. That's point 0. That's point 9 as well as 3. Right. That's point 6. I'm not going to show everything. And also, if you check from point C to 9, it's shown just to give an idea of the triangulation that we are dealing with. Okay. Right. Now, the diagrams are set. Now, what we want to find, right, are the true lengths. Okay. But I'm not going to use the Rabati method now. I want to use another method which is different from what we did last time. So I'm going to create a line like this. Right, take the height from here to there, which is 31, and mark. Okay, so we are going to create right-angled triangles to create the true line. Okay, right. By merely checking, right, you would see that if I were to say this line is A, okay, this one would also be equal to A, like that. Right, if I say this line is B, right, this one also would be equal to B, okay? Right, that's C, that is also C, and that's a D, that's also D. And I'll say this is E, this is also E, then this is F, then this is also F, then this is G, then this is also G. Okay, right. Remember, you are not sure these levels in terms of your work, but you'd realize that as you are coming up with the development, you need to refer, and these references would come handy. All right. Now, there's a line which is from B to point number 6. It's not defined, but I'll call it point line H, okay? From the base point to point number 6, right? Which is H, okay? Right from here to there, as well as from here to there, it's also H, like that. There you go. So I've made this our seam, but as you can see from here to there, it's parallel to the baseline. So automatically what it means that this seam, right, if I label here seam, right, is basically a true length, okay? Because this one is parallel to the base ground line, automatically this one is a true length. Right. Now, let me start with A, right? I'm going to take this measurement, right, with a compass like this, right, stand here, right, and mark like that. Connect this point to that point. Like that. So like this. Take this one down. Right, okay. Let me just recap. We did draw from here, measure from here to there, that's 31, which is the same height as that one. A vertical line and a horizontal line. Now I take the distance from here to there, which is A, from here to there. Then you connect, you would have created a right angled triangle. So this is, that's line A. That is the true line A. Right, I do the same for B. Take this distance, right? You stand here. connect to there. Just use a different mark, right? And I'll say this is my line B, okay? The next one that I require is line C, which is slightly longer than B. Come here, mark here. Right. Let me mark it on the other side to reduce congestion. It's one and the same thing. That is my line C, which is the true length C. Right. D. Open it. It's much longer. Mark this side. There you go. That's D. I have got for E. Take that. Mark this side. That's E. And F. Interfering. Okay. That's F. This could be the same. G. Right. Then H from here. But from the top view, it would appear as if it's just a straight line, but you can see point 6 is at the top and point B is at the bottom. So you need this. Stand here. H. Okay. We repeat this one is a true length diagram. You write nicely TL, true length diagram like that. Right, so that you advise and you show the examiner where to get the true length. Remember the first exercise, what we did, we rabated, so you weren't showing, you did not label true length diagram because it was clearly showing where and how the true length was established. Right, okay. Now, once you have done this, the next thing that you require now is to come up with the drawing in terms of the development, right? This is our seam line from 0 to E, right, which is already a true length. So if I were to start somewhere here, just draw a line like that and say this is my point 0, right, which is here, like that. Take the true length, which is this one, 0 to E, stand here and describe an arc. Okay, let me just extend this. Now, this is my first part. To outline this. But I'm going to outline this from here to there, okay? But from here to there, that's my seam line, which is from here to there. But the next thing that you require to do, right? Remember what you can do, right? You can also draw the circumference or the development of the circle. Divide it into a number of equal parts. If you want to get the exact size, instead of taking from 0 to 1 like that, but we can say the diameter is 42, which is 42 multiplied by pi is equal to 131. So I can draw a line here like that. Measure this market point and 131.9, which is basically 132. Right? And come here, okay? Right. Divide this one into 12 equal parts. Equal parts. Just a moment. Sorry about that. Just checking. Right, the small little canvas. Right, okay. So I said from here to there, right? You have got 12 divisions. I'm going to, okay, let me just fix this, extend this one too, which is 1, 2 like that. There you go. All right, align with this one. You would now take this distance from here Right, okay. Now just check if it is the same. You'll find that this one is slightly smaller, okay? Right, so I'm going to take this one in terms of the distance for my circular spacing, okay, or intervals, right? So the first thing that we want to get to point number 1, right? So I'm going to describe an arc like that. Right. Point 1 is established from 0 to 1, as well as A to 1, which is line B. So I'm going to look for line B, which is here, right? Stand at point E, right? Before you stand at point E, right? Let's first of all establish point A. Sorry, because this is supposed to, right? As you can see, this line 0 to E is meeting DA at 90 degrees. Right, so you can easily draw a line like that, which is perpendicular to the same line. Take E to A and bring it here and mark. Right. Now you have got point A, right, which you would use to get point 1, okay, right? You can connect A to 1, like that. But if you check A, right, if you take the distance from here to there, it will basically be the same. So I'm going to take this one and connect to there, bring it here, but you'll find that it's one and the same thing. So now what we have, we've got A, 0. We now need 0 to 1, which by taking line B, right, which is this one, like that, stand at point A, you describe an arc like that. That is your point 1, right? Take that distance, which is from 0 to 1 and 1 to 2. You get that, right? I need line C, which is A to 2 and 1 to 2. Line C, right, which is this one. Which is this one, like that. Come here, you describe an arc like that. There you go. You now have got point number 2. Once we have gotten point number 2, you need point number 3. Take this distance again, stand here, like that. Right. 1, 1, 2, 0, 1, 2. We need 3. 3 is defined by line D. Line D is here. You take the true distance. The true distance, you come here, describe an arc like that. You have got point number 3, okay? But you can just test to see whether you are doing the right thing, right? Like this. Okay, right, it should produce a curve, okay? Right, remember this is permanent, it's not going to change, so we are also going to outline from here to there. Then you connect these points, connect this point, connect that point. There you go, okay? Now, I have now point 3, right, which means I can be able to establish point B, right, as a combination of connecting A to B and 3 to B, okay, which is our line E. Right, let me start with 3E, right? Let me look for E, which is here. Take this distance like that, right? Then you stand here and you describe an arc. Now, the distance from A to B is the same as this one. They are both parallel. So you are going to take this distance like this. Stand here at point A. You describe an arc. You establish point B. Okay. B is now connected to point A. You also put this one. Right. So we have got 3 to B, right, which is your E. And this can be outlined like that. Now, once we have gotten point B, you can reach point 4, you can reach point 5, you can reach point 6. Right. So I'll take the small canvas, stand at point 3, describe an arc. Now I need F, right, which is here. Stand here and describe an arc. Right. That's point number 4. Point number 4. Right. That's point 4. Next, take the canvas again. Describe an arc like that, so that we have got point number 5, which is line G. Right, still standing at point B. Take this distance. Take this distance from here to there. Right, you come to B and describe an arc like that, which is point number 5. Then I need point number 6. Stand there as well. This is not going to change, it's consistent. Remember, like I said, you can use this measurement, what we refer to this one as the rule of the thumb. It's not correct, but it's acceptable. Right, but if you want to be more accurate, you find the circumference, pi times diameter, divide that into a number of equal parts, in this case 12 equal parts, the same divisions that we have here. Right, okay. Then this one, G, right? G, I've already defined that, which is this one. But now I need H, okay? Like that. You stand here, you mark like this. There is point number 6. Right. You can also test again just to see whether you have done the right thing. You would find that our curve is coming all right. Connect this one to there. And connect this one to there. Those are the triangles which define the concept triangulation. Okay. The next thing that we want is point C. Point C is a result of 6 to C as well as B to C. As you can see, BC is shorter than AB. Okay. Right. So I'm not going to change this one, which is that. Stand, reverse the standing position. Describe an arc like this. Take B to C, which is this, and connect like that. There you go. Right, okay. Right, now this can also be outlined. It's not going to change. There you go. But that's point B, and this is our point A, and that's our point C. we connect this one to there. Right, so this line is G, this one is also G, right? F, sorry, H, just check. Right, that's H, G is this one, which is for 5. Right. Then from there, I need point number 7, point number 8, and point number 9. Describe an arc like that. Right. I needed this one. So I'm just going to reverse. Right. This one is the same as that one. So I take this one, which is 5 and 7, they're basically the same. Right. Stand here. Describe an arc like that. Then I have got point 7, right? Do the same. This, right? Then take 4. It's going to be the reverse. Now we are going backwards. That's point number 8. Then this would take us to point 9, which is E, like that. Then take this one, send it there, describe an arc. So that's point 9. Then from here, you can connect faintly. Right. And these points are connected to point C, point C, point C, like that. Then from here, we now need to get to point D. So it's 9D, C, D, okay? This is the longer side, right? So we now need this one, right? Which is point 3 to A, is this, which is the same as 9 to D as well, okay? But I'm going to take this distance, right, standing at point number 9, describe an arc like that. Then take the longer side, which is C to D, which is this one, stand here and describe an arc like that. Now I have a point D, okay? Right, connect this one to that, and also this one to there. There you go, okay? Now I need 9, 10, 11, and back to 0, okay? So this one is the first one. Remember what I said? But you are just going to reverse this, right? So from here, you take this one now, stand here, and describe an arc, okay? That is your point number 10, right? Stand there again, right? Then take this one up until you get back to 0E, stand here, cut this one, that is number 11, then take this one, which is that, and stand at point D, cut like that. You stand here, you cut this one like that. That is point 0, like that. Point 0, 11, 10, back to 9. that. Connect. Like that. Right. So what we are left with, we are now at D. We want to get to point E. Point E is a description of D to E as well as 0 to E. Right, okay. 0 is already there, D is already there. So all what we need to do is to reach point E. So you take this, which is your DE, which is the true size, state at point D, and describe an arc like that. Take the true line or true line 0 to E like this. You stand there, you cut like that. You should be able to describe an angle of 90 degrees. Right, like I said, this should be tangential to that, and this one should also be tangential to that. There you go. Right, you can now outline this. And also outline that, and you can also go back and outline this one as well. So that's A, B, C, D, right? And back to point E, like that. Then the top part, you can also now outline nicely. There you go. Right. So if we are going to cut the material which should be used for the development of this transition piece, this would be the pattern, this would be the template. So you cut it accordingly, according to this size, true size. These are the 4 lines, they should be indicated, which define a series of triangles. Right, just like we did with the last exercise. Once we have done this, right, you come here, you label nicely, development, transition, piece. That is the development of the transition piece. Boys and girls, I hope you have been following and enjoyed this lesson. Right, so this is it. We have now looked at a number of ways or scenarios that we can come across in terms of transition pieces. Right, I want you to practice this so that you should be able to write your exam with confidence and also be able to write your final exams, which are almost by the corner. Enjoy the rest of the day and good day.